The Department of Material Science and Metallurgy in Cambridge undertakes research at the highest international level of excellence. There are about 100 research fellows, postdoctoral scientists and visiting scientists in the department, and more than 140 research students studying for postgraduate degrees at master or PhD level at any given time.
I'm Aarti Vasudevan. I'm a PhD student in Material Science and Metallurgy. I started off by doing an MPhil in this department, and I continued on to do a PhD in Material Science and Metallurgy. As a child, I was drawn towards chemistry, and I wanted to be an engineer because I wanted to do things. And so I wanted to do chemical engineering, and I couldn't get into chemical engineering. So I thought I'll settle for material science, like metallurgical and materials engineering. And then, to my pleasant surprise, I found out that metallurgical engineering had a lot of chemistry in it. So what really drew me to material science was that metals and alloys are omnipresent. Like every structural component that you see is made of metals and alloys. And with the same composition, you could just tweak the properties with just heat treatment, and you get different properties from the same composition. So I was really drawn towards this microstructure process and property correlation. So that just kept me going, and I wanted to be a materials scientist. The main attraction of this department is the standard of its academics. So what's incredible to me is that I work with Professor Catherine Ray, and she is the professor of superalloys at the Rolls-Royce UTC in the department. Just to closely associate with her, interact with her on every week basis, and just share my results and gain knowledge from her is incredible to me. In addition to using lots of these equipment and learning to use them on my own is quite challenging and incredible. I think this is the place to be if you really want to learn something right and learn something deep and well. So there's indeed a lot of unlearning to be done, and you just need to have an open mind to grasp new concepts and just be in the right spot to understand constructive criticism and work on yourself. Just have an open mind. And I think this is the place to be if you really want to answer the question of why and how, not just what.
We nurture a positive research culture, and through training with world-leading academic research staff, as well as access to state-of-the-art research facilities, our graduate school has the mission to train the next generation of material scientists and develop advanced materials that will support the global challenges of climate change, energy and material sustainability, and the aging population.
I'm Marcel Moldavsky. I'm studying an MPhil in Micro and Nanotechnology Enterprise, which is a course both taught and by research. My domain is quantum devices, and I'm now into the research phase of my course, working on quantum computers in the Hitachi lab with my supervisor. The presence of material science in your everyday life is what raised my interest. When you scroll through your phone and you want to know what happens between the tip of your finger and the icon on your screen, that's something that drives me into this field. This proximity of material science in everyday life was something that drew me into this area. Material science at Cambridge offers those with creativity and business mindset the joy of abstraction, the joy of reinventing certain solutions on many different levels.
So I come from a chemistry background, and initially I wasn't particularly oriented towards material science, but the research projects that I was more interested in were all in this field. I completed a master's in nanoscience and nanotechnology in the Department of Material Science, and coming from chemistry, that gave me a better background and better understanding about the kind of fields I could go into for my research project. So I think what attracted me to material science in particular was that I was able to study both fundamental science and look at devices from a very scientific point of view, but also apply all of this to real world problems and real world applications. So really bridge that gap. between these two things, I think material science is a great place to do that.
Many of our PhD students progress to postgraduate research positions in UK or abroad, and many of our PhD alumni go on to lead their own research groups at top international universities or industry.
Hi, I'm Duncan Johnston, and I lead a data analytics group in the pharmaceutical industry. I did a PhD and also postdoctoral research in electron microscopy and analysis of that electron microscopy data. As I say, material science for me is really about applied physical science, using physical science to do stuff that's interesting in the world. And I wanted to come to Cambridge because I'd already got a material science background before that. So I knew I wanted to work in this area. I knew I wanted to work in electron microscopy, and I wanted to find the best place to do that work. And the great thing about Cambridge was that it had a new purpose-built facility for doing electron microscopy, which is fairly unusual. And that really provided the platform for all the work that I did in my PhD. The other thing, of course, is that working on a technique, you need to apply it to some materials. So you need to find people to work with who make materials. And this is a department which has lots of great research going on, so you can find loads of people to work with. So I had a really great time at the department. I really enjoyed being here. It's quite a small department in terms of its size, but the quality of the work that's being done within that department is really great. So there's lots of people that you can work with, even though it is small. And that means that it's tight-knit, it's got a sense of community, people are very collaborative, and that's great on the research side, but also in other areas like wanting to teach, supervise students, be mentored yourself. All of those aspects come into it as well, and it was a great experience overall.
At the Department of Material Science and Metallurgy in Cambridge, we offer several advanced degrees at master and PhD level, with a thriving graduate school of international students from all over the world. Our one-year MPhil by Research course provides further training in research and development of material science after a minimum of at least a 3-year UK bachelor's level degree or overseas equivalent. Students on this course undertake cutting-edge research on a topic they develop with their academic supervisor. The research can form the basis of a PhD or provide outstanding training for those that wish to go direct to industry.
So I enrolled into this MPhil by Research program, which was like a year-long research master's. So you're collaborating with an industry, you may or may not, but I collaborated with an industry, and it was like a primer for research, it was like a primer before PhD. So you take a year long to introspect if you're really cut out for research and if you really want to take up research as your career. And that whole year was an introspective year for me. And to be able to come up with experiments, like design experiments, and learn a lot of literature, assimilate the knowledge, and then to conduct your own experiments and get results and just come up with your own findings was the key highlights of MPhil by Research program in this department.
We also offer a 1-year taught MPhil in Micro and Nanotechnology Enterprise.
The MPhil in Micro and Nanotechnology Enterprise is designed to give students the opportunity to learn more about nanoscience. Our students tend to have first degrees in materials or engineering, physics or chemistry, but they focus here on reaching a deeper understanding of the nanoscale properties of materials. Alongside lectures, we offer characterization practicals and courses on nurturing and managing innovation in science, science communication, ethics and responsible innovation, which are essential aspects of an education in nanoscience. After 2 terms of lectures and coursework, our students spend 10 to 12 weeks working full-time on a research project that they select or design with their supervisor. Projects can be related to any area of micro and nanotechnology seen from a scientific or from a business perspective. This tends to be a very valuable experience for our students. After graduation, about half of our MPhil students take jobs in industry or business, while others move on to PhDs in Cambridge or other interesting places around the world.
My MPhil course focused directly on introducing the scientific ideas into the market. We had an entire module on patenting and turning an idea into a business model. The department is as close to the tech industry as is possible. For anyone studying and researching at the department, for those who are creative, skillful, and want to solve problems, that is something absolutely that can be achieved at Cambridge at the very highest level. The full collaboration with industry pushes people and their ideas directly into the path of the tech industry. My supervisor had a contact at the institute where I have successfully applied for an internship, and this is in Japan, which demonstrates the connection between the MSM at Cambridge and the industry.
Students undertake horizon research and work within a research group under the direction of an academic supervisor. Many of our PhD students progress to postgraduate research positions in UK or abroad, and many of our PhD alumni go on to lead their own research groups at top international universities or industry.
I think one of the things that I found most important from material science is that as you begin your PhD project or your master project, it allows you to first discover everything that you can do with it, and then really specialize after you find out what's more suited for you, what you're more interested in. And so it gives you this broad approach in the beginning, which opens a lot of doors, so that you can really tailor it to yourself. Within the material science department, there's a lot of collaboration within different groups in the department, but also outside the department. So we collaborate a lot with other STEM groups. And on top of this, we also work a lot with industry, which was really an upside of my PhD program.
The industry collaboration was a really core part of both why I do material science and the work I did as a graduate student. And it was wide-ranging. So I worked with some of the groups in the department that are directly funded by industry on jet engine materials. We also worked with polymers from companies in the chemical industry. And then ultimately I ended up working with pharmaceutical industry partners as well, which led to what I've gone on to do. On that pharmaceutical side and my particular research area of electron microscopy, there was a consortium of different industry partners that all worked together within this state-of-the-art facility that they had. And that sort of provided a nexus for bringing ideas together, doing some research, and ultimately led me to meet some people that I now work with every day.
So my personal ambition is to enter the world of startups and entrepreneurship. And I think material science, and in particular a PhD program, allows you to understand the fundamental science at the base, which then can be applied to so many different real-world problems. And you can take a commercial approach to this, and it really doesn't limit your options. If anything, it opens a lot of doors.
So I think that material science is a great subject, and I'm really passionate about wanting to use applied physical science or material science to do good things. And why do material science at Cambridge? I think it's a really collaborative environment, the research ecosystem within the department, but also beyond the department, in all the other academic areas that you have, but also the startup culture that goes with Cambridge, and the richness of both the university, college and town environment really adds to the Cambridge experience. And I think it's great.